Okay, welcome to the appendix. This is just a little addendum surrounding the course project. Remember I mentioned at the end of the last chapter, chapter 18, that the best way to solve the course project storage problem was to use something like a linked list, a truly dynamic storage allocation mechanism. You may not know what a linked list is. Well, if you don't, I'll just give you a very, very brief synopsis now verbally. Think of a structure, any old structure, a CD structure in particular. A CD structure that has as one of its elements a pointer. A pointer to what? Well, a pointer to another CD structure. Yes, that is possible. It is possible to have, if you like, a recursively defined structure, a structure that refers to a pointer to itself, or a pointer to another structure of the same type, if you like. So what you have then is you have your first CD contains within it a pointer to the second CD, and the second CD contains a pointer to the third CD, and the third CD to the fourth, and finally when you get to the last CD, which might be, say, the 10th CD, the pointer on the end of that one is null, denoting that is the end of the list. Now that is what a linked list is. Coding one, however, is a lot more difficult to describe than simply the actual description of the list itself. The reason that this is an ideal solution is not because it's easy to code, is because it gives you infinite amount of data storage, or rather as much memory as you have on your computer you can use to store the list. You're not limited by anything, and you don't have to do that yucky mallocing and reallocating all the time. You do actually have to malloc each node in the list, each CD, if you like, but you don't have to do any silly reallocating. I really don't like realloc. It just doesn't work most of the time. I mean, it works, but it doesn't allow you to access as much of the memory as you might like. Anyway, thinking along the lines of generic code, if you had a linked list of CDs, would it then be possible to have a linked list of something else, say a linked list of employees, or a linked list of bananas, or a linked list of integers? And the answer is yes, of course. And the trick is, the really clever trick is to write a set of generic linked list routines that allow you to create a list of anything, allow you to add things to the list, to delete the list, to delete one element from the list, to sort the list, to do all sorts of things. If you can write a set of generic routines to do that, you can use that set of routines over and over and over again, no matter what you wanted to keep track of. And that's exactly what I've done. I have written over the years, I guess, a set of generic, completely generic linked list routines. And I've just amalgamated them into the course project. So I'm not going to go through this with you line by line like I did with everything else. I'll just leave it for you in the chapter 19/lists folder. And you can go and have a look and see how it works. I've added two new files to the project, one called glist.c and glist.h. The G stands for generic. So all I've done is I've rewritten the program using a different data storage technique, linked lists, which is probably a good storage technique for this sort of program, and you can go and have a look at the result at your leisure. In fact, it is a doubly linked list library. If you don't know what a doubly linked list is, it doesn't really matter. It's simply that each node in the list not only refers to the next node in the list, it also contains a pointer to the previous node in the list. Now, the actual solution that I provide, the library and the solution itself, is a really excellent example. I'm giving it to you not because I just want you all to have my code. I'm really giving it to you for educational purposes. It is a truly excellent example of function pointers, reusable code, advanced pointers. It really does a lot of, not so much clever things, but things that you're just going to need to know how to do over the course of your programming life. It provides a marvelous piece of example code. And yes, it is example code, but it is useful. It is industrial strength. It's fully tested. It's, to the best of my knowledge, bug-free. I've been using it myself for quite some time. It's reusable. You can use it to store a linked list of anything. And so I give it to you. You may use it yourself any way you like. You may use it at work, you may use it at university. You can even sell it to your friends if you want to. I don't mind. It is my gift to you. It's a little added bonus. I give it to you simply because I think you need to have at least one piece of reusable code in your library. Okay, so take it with my blessing. That's the end of the chapter, and it's also the end of the appendix. And we'll just, on the final slide, we'll just have some closing